People already here right on the hour. Thank you for joining us today. Super excited to talk about this topic. It's something we talk about a lot with our customers and prospects and analysts. And to get started, there'll be a few small logistics here. Get my screen going. There we go. First thing I'm going to do is actually push some polling questions to folks. So you might see some polls come through. Feel free to participate. I think it's a great way to learn about each other, what everyone's working on, and for us to learn about what your priorities are and how we should think about what we build. But a couple other logistical items. So one, the lines are muted, but we want this to be an interactive and engaging session. So please use the live chat. You can ask your questions there, you can share where you're from, make friends. But we do have people in the audience who will be manning that chat to answer your questions. We'll also do a Q&A at the end where we respond to your questions directly. So you can put them in chat now, we'll get to them at the end and also answer them throughout. We did also just share the slides in the handout section. So there's polls for you to take. There's some slides you can download from the webinar today if you want to see all the great content on your own. And then also I always encourage people, if you want to try fine-tuning small language models for your use case and serving them, you can try out Protobase. There's a link there to get $25 in free credits, which is enough to fine-tune a couple models like Llama 3.1, the new hotness. I'll put the link in chat too for folks. All right, we have a lot of content, so I'm going to jump in, do some brief intros. So I'm Michael Ortega, I lead marketing here at Protobase. Excited to be joined by Devitt Rishi, our founder and CEO, and also Abe Malik, who's a product lead here. We've had thousands of conversations across all of us with prospects around this topic. How do you reduce your Gen AI spend and specifically your OpenAI spend? So lots of insights to share, best practices. But before we jump into all the sort of tools and techniques for reducing your spend, one of the things that we want to sort of anchor on is something that we hear pretty frequently. I'm sure many of you have probably said this. Most of the companies we talk to start with, will tell us, hey, I've built this really cool feature, this new capability with OpenAI and GPT-4, but have no plans to actually put this in production. So there's a big why there. Like, why not? You have built this really cool thing, cool widget. Why not put it in production? Well, look, OpenAI, GPT-4 is great. We're not going to lie. We're not here to say that it's not a great tool, right? Many of us have used it. Many of you on the call, on the webinar today. It's developer friendly, right? With simple APIs, you don't have to be a machine learning expert. You can build some new Gen AI capabilities pretty easily. And GPT-4, right? You're going to get great quality on many, many use cases. And in just a test environment, low volume, you're building a prototype, it's relatively inexpensive just to get started. But as we like to say, GPT-4 and OpenAI is great until it's not. And there's actually quite a few pain points that we see pretty frequently with the companies and organizations we talk to, right? First and foremost, ownership and privacy is a huge pain point. If you're building some sort of mission critical feature for your business on top of GPT-4, you're deferring that critical IP that you own that model. You don't own that model, you don't own weights. They can change it. You don't have it, right? That could be critical to your business. That's a big pain for many of our customers and prospects. Also, the concerns on sharing data. Latency can also be a big issue if you have a real-time use case where you need sub-second or second response to customers who are querying a service. Obviously, with GPT-4, you can hit sort of rate limiting, and if there's a 1, 2, 3, 4 second delay in a response, that can actually break the customer experience and create a really bad experience. And then what we'll be talking about today is when you start to put these projects in production at scale with production traffic or expand use cases, it becomes incredibly cost prohibitive and hard to actually justify that ROI on that project. I'm sure many of us have seen tweets like these. You might have even written them yourselves. But I think there's an important point here, which is, one, they're kind of funny, but I think it's important. Like, many use cases with OpenAI start at could be $1,000 a month. That feels very palatable, and then suddenly you wake up and you're having to explain to your CEO or your management team, why am I spending 20, 30, 40,000 a month on a single use case? And I think that actually there's a broader sort of macro and sort of meta point here that, obviously OpenAI is a big cost expense. We need to be cognizant of that. But the bigger point is, look, we spent the last 2 years many companies investing in Gen AI capabilities, right? In an effort to build new products, to get out in the market and gather market share very quickly. But many of these projects are very experimental in nature. And we're now kind of getting to that point of trough of disillusionment where we have to start justifying to our management team, to our CEOs, our board members, right? Are these expenses actually generating value back into the business? So we have to move from just experimentation to true being able to demonstrate ROI. And it's, I think it's, obviously we're going to focus on OpenAI cost, but the sort of macro point here is that we need to start thinking about optimization of cost, right? We can't just do experiments forever. And so we'll talk about GPT-4 and how to reduce that cost, but this is just a bigger trend that's coming in the market and a headwind we all need to be aware of. So before we talk about all the cool sort of techniques and things you can do to actually lower your OpenAI spend and things we've done in our platform to do that, let's do a little sort of experiment, right? How do you go from that $1,000 a month of GPT-4 costs to that $200,000? It's actually not that hard. So for this exercise, we're going to use this made-up company called GPU Warehouse, right? They're an online retailer, mid-size, pretty popular. They sell GPUs and other cool tech that we all love. In this company, they want to reduce their customer support costs. So they're looking to automate chat on their website. Now, they're not looking to build the most sophisticated chatbot, just very simple task. When someone writes a chat request or query on their website, they want to just classify that. Is that a billing question? Is it a shipping question? Is it some product feature question? And then serve up just a link to a relevant FAQ article. Now, for this website, we're going to say they have roughly 20,000 daily visitors. Pretty palatable considering sites like Gap or BestBuy.com have millions every day. This is like your true mid-sized company. On average, industry benchmark, about 15% of your users on your website are going to engage with your live chat. And then, if we say like on average 5 messages per chat, that's roughly 15,000 messages, right, that you're going to be pinging GPT-4 with. It's a pretty low token actually use case classification task when you're outputting a classification value is not very high, right? That's about 10 out, maybe a few sentences into that chatbot. So pretty low volume, use case when you actually think about it. This comes out to about 45,000 using the actual like GPT-4 cost. You can go to their website and calculate this out yourselves. This is a real cost. That might be palatable for a use case that has helped you reduce the number of like live attendees you have to have on your chat and streamline some of your website chat. That's not too bad, right, for an annual cost. But like most use cases, you want to evolve that use case. You want to make it smarter, right? Perhaps you have people coming in that chat who are high value customers spending $10,000, $20,000 on hardware. You want to flag that as a high priority ticket, and that's another great GenAI use case prioritization. And then for those, and route those to a live human. For those that you want to keep the automated experience, you might have an agentic workflow where instead of just giving an FAQ article link, you want to summarize that FAQ article right in chat. And then before you send that summarization over to the user through chat, you might want to run it through another call to GPT-4 to just do an editorial pass. Pretty common sort of workflow for a chatbot. Now that use case that was 10 tokens out is 600 out, quite a bit more. And the cost has gone from $50,000 to $250,000. This still may be palatable because you've reduced the number of live attendees you need for support, and you've streamlined, improved the customer experience, seeing less churn. But use case has grown significantly. And like most LM use cases and GenAI use cases, you want to expand this to other parts of your business. You don't want to stop at one use case. The intent was never to do just one use case. And so you want to, for example, bring this into your call center, automate email response. Similar task. To make this simple, let's just assume similar amount of tokens. We're now at another 255K. So a use case that costs us 45,000 a year, so maybe a few thousand every month, like that tweet, has now ballooned to like 40 to 50K a month. And then, like any healthy business, you can expect your business is going to grow. Your users might double. You may expand this use case to more users and new audiences. And so that cost, again, was $45,000 at the beginning of the year for this little GPU warehouse. It's now upwards of $1 million. And so it's very easy, as you can imagine, starting with one simple use case with GPT-4 and then seeing that cost balloon.
And I think that, we see this from customers all the time. And one of the really exciting things is that just in the last week, we've seen a massive massive confirmation that this is an issue that we can start to go ahead and tackle at an increasing rate with the open source. And so last week, we with the announcement of Llama 3.1, the open source AI model you can deploy anywhere. One of the things that I personally found the most interesting about it was that with all the capital expenditure that really went into the development of this model, some of the key things that Meta called out as what this model could be developed for is to be able to use it to fine-tune, distill, and deploy anywhere. Meta released 3 different versions of this model: an 8 billion parameter model, a 70 billion parameter model, and a 405 billion parameter version. And I think that key motivation for having these different variants is that customers can now get a different cost curve depending on the level of quality and expenditure that they might want. So in particular, the idea that the 405 billion parameter model might be something that can be really distilled into a fine-tuned, smaller 8 billion parameter model that can then be self-hosted by a customer and then save them a significant amount on cost. If we go to the next slide, I think Mark actually spoke a little bit about why the time for open source LLMs is now. And there's a number of different, I think, parameters here. Training and fine tuning and distilling the models is a huge aspect for why organizations might want to be able to adopt one of the open source models and not be locked into a given closed vendor. But a massive area for like why I think a lot of us are bullish on the open source ecosystem is that it just allows you to effectively run the models that are efficient and affordable in terms of what you actually want to be able to support over a longer term. And so I think in this particular area, in this particular letter, this was reflected as something that Mark had heard when talking to developers, CEOs, government officials relatively consistently. And I would say this is a huge aspect of like what we hear from a lot of our customers today as well. These key points, oftentimes driven by a motivation to be able to future-proof their deployments at a very cost-effective scale. And if we go to the next slide, I'd say one of the things that probably has been holding folks back the most in the past from switching towards these smaller open weight models that can be self-hosted at a lower cost is actually this idea of making sure that it's quality competitive with what a user might want to do. And I think honestly, about a year and a half ago, there was a significant gap between the closed source and proprietary models and some of the open source models that users might be able to go ahead and use at a much cheaper rate. But one of the most compelling things in particular over the last quarter has been how much this gap has exactly closed. And I think that the closing of this gap really brings us back to one of our favorite customer quotes, which is, why am I paying for the biggest model that might be out there? Or again, this idea that generalized intelligence is great, but I don't need my point of sale system to recite French poetry. When I have a very specific task that I want my large language model to be able to do, I don't necessarily need to pay for the largest amount of capacity that is overkill for that individual area. And so what we wanted to do in this webinar is go through a little bit of this context about why we're bullish on being able to save significant amounts for any person that's using a Gen AI application in production today. And over the course of this webinar, we're going to be highlighting some of the key aspects for why and how users are able to save kind of on their Gen AI production deployments. So if we go to the next slide, kind of the key aspects of like where I think users are able to save is in how they maximize the model. So essentially get that big model quality with the small model footprint, and then maximize the underlying hardware that they're using to be able to serve these models as well. So I'll hand it over to Abe, who's going to walk through both the techniques as well as some case studies of how we're able to save on Gen AI expenditure.
Awesome. Thanks, Dev. Let me go ahead and share my screen. Can you all see my slide?
Sure can, Abe.
Sweet. So yeah, as Dev mentioned, today we're going to cover 3 main ways to lower your OpenAI bill. Before we dive in, I think it's important to recognize that there are 2 main buckets you may fall into yourself. I think one is you have a large OpenAI bill today, and you and your CFO are not very happy with it. Or 2, you have the volumes for a large OpenAI bill, but you're holding back, either via limiting the use cases or limiting the traffic from really deploying Gen AI at scale. And so for both of these use cases, the techniques we're going to walk through today will help you decrease your overall AI spend at scale and show you how you can go from OpenAI to open source. And so what are these techniques? The first one is leveraging small models to go ahead and rival GPT-4 performance at a fraction of the cost. The second is accelerating throughput. So that basically means increasing the speed of generation so that you ultimately have lower costs for your use cases. And then third is using multi-LoRA serving to maximize the utilization of your GPU and infrastructure. And then as Dev mentioned, we'll also dive into some case studies from our customers to give you a real sense of what this looks like in practice. Cool. So while it's very common, again, to start with OpenAI, we really believe that using smaller, fine-tuned open source models when you're ready to move to production provides a better set of trade-offs. And so when we talk to organizations today, we find that while using a large model like GPT-4 is like as a hammer is fine, what folks are really trying to do is solve very specific use cases. So imagine code generation for a domain-specific language, or summarization of customer support tickets, or even customer sentiment. And so by using these open source models, you see a variety of benefits, including the ability to, 1, own your model, 2, no longer send data to these commercial providers like OpenAI or Anthropic, and then 3rd, finally make use of smaller and faster LLMs where you can control the output and reduce the kind of hallucination rate. So to see this in practice, we actually fine-tuned 13 of the leading open source LLMs across a variety of different tasks. And honestly, we were surprised to see ourselves that around 85% of our fine-tuned models outperform GPT-4. And so what does that mean for you? What should your takeaway be? I think the very first question that organizations think about when they look to deploy an LLM use case is really around quality, right? And how can I get best-in-class, top-notch performance on my use case? And so what we've shown with this collection of over 700 experiments is that there really are only two ingredients you need to outperform GPT-4. One is a leading open source base model, which you can see from this fine-tuning index. And two is a fine-tuned data set. And so once you've established that you can actually meet GPT-4 quality, the next question we hear customers often talk about is cost, right? Which is obviously the focus of today's webinar. And so as we'll see in the rest of the presentation, small models just blow large models out of the water when compared to both cost and quality. And if there's one kind of clear message that we hear a lot from our users that sort of combine these two axes of quality and cost, it's really this idea that, hey, we want GPT-4 quality at GPT 2.5 prices, right? And so how do you do that? I think the secret for us is fine-tuning. And so since our audience typically varies in their expertise with fine-tuning, I did want to take a few minutes to just kind of give a brief overview and really tackle some of the questions that we see when customers are first starting to fine-tune, right? And so two of these questions are, one, what's the best modeling approach to fine-tuning? How should you think about doing it in a way that both maximizes quality, but at an efficient cost? And then two, how can I go ahead and curate an effective data set for fine-tuning to maximize the performance of my smaller fine-tuned model? And so starting with the first one, what actually is the best modeling approach for fine-tuning? Maybe you've heard some terms, but you're not sure where to start. Let me go ahead and give you a quick overview. So in the world of fine-tuning, there are broadly two different methods. One is traditional full fine-tuning, and the second is parameter-efficient fine-tuning. In full fine-tuning for LLMs, you have your data set, and what you're really doing is updating the full weights of the model parameters during each step of training. The problem with full fine-tuning, as you can imagine, is that when you have open source LLMs that are 8 billion or 70 billion parameters, updating each and every parameter can be slow, memory intensive, and honestly just expensive, right? And so what if there was a better way? And that's where parameter efficient fine-tuning comes into play, right? The way this works is instead of adjusting all of the weights of the model, we actually just introduce a new set of smaller trainable weights and only update these additional fine-tunable parameters during training. And so the result is by keeping the base model the same and the new set of weights being trainable or what we call like an adapter, we're able to actually see equivalent performance to traditional fine-tuning with a fraction of the resources. And so while it may seem, I think, counterintuitive that, oh, how can I get equivalent performance while only modifying a certain subset of parameters? There's, I think, a few reasons that kind of form the intuition for this. I think one is that during pre-training of these base models, most of the knowledge is kind of learned during that phase, right? And so what we're really doing is we're taking, hey, I have this large language model and I want to customize it or tailor it for my specific task, right? And so it's not that we want to change the entire model and all of the weights. We want to actually leverage the knowledge of this LLM, but tailor it to my specific task, right? And that's what these additional fine-tunable parameters are doing, is learning the intricacies and semantics of your specific task, right? And then on a second point, at a more fundamental level, we're also reducing the idea of catastrophic forgetting, which is basically this idea that if you're modifying all of the parameters of the pre-trained LLM, you may actually start to forget some of the knowledge that was previously learned during pre-training. So things like grammar and language semantics while you're learning information about your new task. And so this clear separation allows actually for better performance in a very cost-effective way. And so one of the specific techniques for PEFT that we like to use internally and has gained a lot of popularity is called LoRA, and it stands for low rank adaptation. The idea is similar to before, where we're still going to pass our inputs through a forward and a backward pass, but instead of updating all of the pre-trained weights, we're going to insert now two linear layers, A and B. And what's unique is that while A and B are individually very small matrices, when you multiply them together, they actually have the same shape as the pre-trained weights, which means you can clearly just add them, right? And so to give you a sense, they're roughly on the order of like 0.1 to 1% of the full pre-trained weight matrix, right? And so during the forward pass, the input of the previous layers is passed through both the pre-trained weights and the LoRa layers, and then summed together before passing it to the next layer. And then during the backward pass, we actually keep the pre-trained weights frozen, right? So we're not modifying them, and we only learn the new LoRa layers A and B, right? Cool. And so what makes this really, really powerful is not only that we have equivalent or even better quality, but it's really that we're using 0.1 to 1% of the total model size and parameters, right? And so the number of trainable parameters is largely influenced by a parameter called rank, which you can increase if you want the model to learn more complex behavior, or decrease if you want the opposite, right? And so beyond just a lower memory footprint, we see that the jobs are also much faster and cheaper to train. And so on average, compared to full fine tuning, it's about 15 to 25x cheaper and 10 to 12x faster to train, right? Cool. And so the other most common question we usually get is, how do I best curate an effective data set for fine tuning, right? To go ahead and maximize the performance. I think there's usually two categories here. One is either you have the data set on hand, in which case, what are you waiting for? Go try out Protobase today, or you don't. And if you don't, then that's where there's an approach that we and Meta are increasingly bullish on, that Dev sort of alluded to earlier, which is model distillation, right? And so just to kind of give you an overview in case you're unfamiliar, model distillation is essentially this idea that you can replicate the performance of a larger model with a smaller one. And so in some circles, this is called imitation learning because you're actually imitating the behavior and the performance of your larger model, right? To kind of give you a high-level workflow of what this typically looks like, what you do is you start with a seed set of, let's say, 10 to 20 examples. These are usually hand-labeled. You feed that data set to a larger LLM, and you say, hey, can you generate, or can you expand this small data set into a larger one? And then you use that new data set, in this case, that was synthetically generated, to go ahead and fine-tune your smaller model, right? And so the intuition here is that you're actually, the synthetic data set that you create sort of captures the knowledge of the larger model, right? And you're transferring this via fine-tuning to the smaller model, right? And so the kind of main components here are you have your teacher model, which is a larger model. I think in the past, people have used like ChatGPT, but I think what's really interesting with this Meta 4.5b launch is that this is actually one of the main use cases that they're really pushing, right? Is that, hey, we have this large model, and we actually want people to go ahead and try to distill, right? And then, of course, what do you distill into? You distill into the smaller model called the student model. And this is the model that you want to fine tune, right? And of course, if you're deciding, hey, which model should I choose to go ahead and use as my student model? That's where you can use our fine tuning index that we talked about earlier to kind of see benchmarks across a variety of different data sets and figure out what is the best base model for you to use for your task. Cool. And so this is actually just a sneak peek of what we have coming up. Next week, we're planning to do a deep dive into some work we're doing on model distillation and showing how you can actually outperform GPT-4 with only 10 rows of data. And so if you fall into that second bucket where maybe you don't have a data set or you have a very small one and you're looking to see how you can expand that and go ahead and get started with fine-tuning open source models, definitely go ahead and register for the webinar next week. It's at pbase.ai/distill, and we look forward to seeing you there. Cool. So now that we've covered kind of building big with small open source models, the next two items I wanted to cover are really around maximizing our GPU. And so I'll start with how can we go ahead and maximize throughput, right? There are a variety of techniques that we use internally at Protobase, but the main technique I'll start by covering is this idea called speculative decoding. So what is speculative decoding? In case you missed one of our previous webinars, the main idea of speculative decoding is, what if we could correctly guess future tokens generated by the LLM? Well, if you could do this, then in theory, you no longer have to generate one token at a time. You could actually generate, say, 2 or 3 at a given time. And then the question becomes, well, if I can do that, well, how would I do that, right? How does this work in practice? And so I think one sort of naive approach you can imagine is that I have two steps. One is the draft, where I guess the next K future tokens. And the second is sort of a verification step, where I say, okay, I have these K tokens. Can I go ahead and evaluate correctness of the guesses? And I think the key takeaway here is if this process is both cheap, which means it has like very little overhead, and two, we can guess them correctly, it's pretty easy to see how this can speed up generation, right? Because if you can guess 2 or 3 tokens at a time consistently, obviously you can go ahead and like double or triple your throughput, right? And so now that we know what speculative decoding is at a high level, how do we use it at Predabase? So we actually have this feature called Turbo LoRa. There's a lot going on in the slide. We won't kind of dive too deeply, but this is actually a preview of a feature that we're going to publicly release in the next few weeks. And the feature that we're calling Turbo LoRa, well, first we're calling it Turbo LoRa because it results in higher throughput, but also because it marries 2 different ideas. One is speculative decoding that we just kind of covered, and the second is that LoRa-based fine-tuning that I mentioned earlier in the talk. And so instead of having, let's say, a separate draft model that we talked about in the last slide, what we can do is we can actually have new projection heads or speculators to the output of the original model. And the main idea here is we can actually jointly train these speculators and Medusa heads, as well as the LoRa weights. And so we do this by inserting both LoRa A and LoRa B, again, these 2 new linear layers, make them trainable. And what's going to happen is these LoRa layers are going to learn the task-specific characteristics, while the Medusa heads will be focused on using that learned distribution to predict the kth to kth plus nth tokens, which again are speculative tokens. So why does this all matter? So we see that, and I think I want to kind of call your attention to the green and the orange bar. So the green bar is, let's say, base model plus LoRa, so your typical fine-tuned model throughput. And then the orange is actually going to be your base model with Turbo LoRa, right? And again, Turbo LoRa is combining this idea of LoRa plus speculative decoding through a joint training process. And so what you can see if you look at these green and orange bars is that for Kana LLP, which is an NER task, we're able to go ahead and see throughput improvements of over 3.4 times from this fine-tuned model to the model trained with Turbo LoRa. And then on Magic Coder, which is a code generation data set on the right, we also saw about a 3 times increase in throughput. What's not shown here, but it's still very interesting because it's important, is that we actually achieved the same or better model performance across all the data sets and benchmarks that we ran internally. And so our sort of takeaway is that, yeah, consistently using Turbo LoRa gives you maximal quality as well as a fine-tuned inference performance, right? And so you really get the best of both worlds in terms of the quality as well as the cost as a function of throughput. And of course, if this was definitely like a very high level speed run through speculative decoding and a preview of our new feature, but if you are interested in learning more, we do have a webinar that we've run in the past that kind of deep dives into this topic, as well as a blog post that we'll be releasing shortly on Turbo LoRa. Cool. And so the third and final trick we'll cover for today for cost savings is multi-LoRa serving, right? And so this is, again, making use of LoRa-based training, but now during the inference process. And so if you think about a traditional LLM deployment, typically the way it works is you have to serve one LLM on a single GPU. And so what that means is, let's say you want to serve 5 LLMs or 10 LLMs or even more, right? As you sort of scale your costs and scale your use cases. What that means is, yeah, you'd have to go ahead and serve on using a separate dedicated deployment or a separate GPU for every fine-tuned model. And so we sort of saw this problem and thought, hey, what if there was a way to go ahead and serve all 10, 15 models on a single GPU? And so this is actually the core motivation behind our open source project called LoRaX. Some of you may have heard of this if you haven't already. But LoRaX essentially stands for LoRa Exchange. And again, this is like an open source inference project, which gives users ability to efficiently deploy multiple LLMs using the same deployment. And the sort of high level idea as to why this works is because if you use LoRa-based fine-tuning, if you remember, what we're actually training is not the full base model. We're not modifying those weights at all. We're actually just training these new smaller, much smaller LoRa weights, which we call adapters. And so what we can do is actually say, hey, we have a single base deployment with the same weights, and we can dynamically load in these adapters at runtime. And if we do this in a smart and intelligent way, we can schedule these requests with minimal latency, right? And so what you get is an equally or very similar performance in terms of inference, but at much of a fraction of the cost, right? Where you don't have to scale across multiple GPUs for every fine-tuned model. You can actually just have one deployment that goes ahead and serves all of your use cases. And so just to kind of show this cost savings visually, LoRax allows you to serve up to hundreds of adapters on a single deployment. And so if we kind of compare, let's say like GPT-4 versus Predabase, we can see actually here that Predabase is just a static cost over time, again, because you pay for that one deployment, and then you can add as many adapters as you want. And again, an adapter is just synonymous with a different fine-tuned LLM. This is in stark contrast to something like OpenAI or a commercial vendor where you not only pay increased costs for fine-tuning because they charge higher rates for inferencing on a fine-tuned model, but you also then scale those costs with volume as well as use cases over time, right? Which then becomes unmanageable and then brings us to this whole thing of, hey, why are you paying so much when you're actually just trying to get Gen AI in production, right? And so if there's a way to scale that cost effectively, that's kind of what we're here to show you. Cool. So at this point, let's say you're bought into this idea of fine-tuning smaller open source models as a way to rival GPT-4 at a fraction of the price. You may be wondering, should I build this in-house or should I go ahead and buy a platform? And while this is a pretty complex decision with multiple dimensions, I did want to give at least a high-level picture of how we think about it. And so if you were to build a full platform, I think we see teams typically require around 3 to 5 machine learning engineers. This consists of people that both have machine learning expertise as well as infra. And usually it takes about 3 to 6 months to go ahead and get a working solution that stitches together all of these open source frameworks. And so some of the things you can imagine having to kind of wrangle with are one, like data connectors to go ahead and pull that data in real time, going ahead and having best-in-class training, or version control with something like MLflow, going ahead and running inference on maybe a project like Lorax that we actually put out, and then going ahead and finding spare GPUs on RunPod or any of these GPU providers, right? And I think the challenge is to do this well, because of course it's not probably too terribly difficult to make a POC with this, but to do this in production across multiple use cases is where the challenge really starts to become sort of like an iceberg type problem. And the tough part is even once you spend the 3 to 5 months to go ahead and get this in place, you now have to maintain a team to keep this up to date, right? With a lot of the latest research practices, both on the training side as well as the inference side. And I think that's just speaks to not only just the initial setup cost, but the ongoing maintenance that you have to kind of put in over time. Of course, on the other hand, we've seen actually one AI engineer. So again, no need to be very experienced with ML. We've seen software engineers that are ML curious be successful with Predabase. And so I think that's mostly because we kind of have seen what it requires to build this in-house. And we've done that, right? And we've done that with the best-in-breed platform. So we have neatly packaged data connectors to all of your sources like Snowflake, Databricks, BigQuery, a best-in-class fine-tuning story, obviously, and then a production-grade inference, all in a single platform that you can deploy in our SaaS platform or in your VPC if it's interesting. And all that said, I think this is a decision that we do see teams facing. And so if this is familiar, don't hesitate to reach out. We can try to give our unbiased opinion, because there are some cases where it does make sense to build, right? And so we're happy to kind of walk you through what we've seen work well. Cool. So now that we understand some of the ways you can reduce your OpenAI spend, let's go ahead and see this in practice with some customer case studies. Cool. So the first case study we'll cover is one of our customers, Checker. You may have heard of, but they're a late-stage growth tech company. For some background on Checker, they essentially do employee background checks. And so what does that mean? That means they help streamline the process of hiring. So when you hire a new employee, how do I make sure that this employee is like verified and ready to work? And one of their key stats is that they complete over like 80% of checks in less than like 15 minutes. And of course, because of their easy to use software, they have over like hundreds of thousands of customers, including some really nice brand names like Warby Parker and Domino's. And what's interesting is actually their software is used by both employers to go ahead and obviously provide those like fast and accurate reports, but also used by employees so that they can have a transparent approach to kind of seeing what's going on with their status checks. And so the challenge that Checker had was they had a classification task where they needed to go ahead and extract and classify relevant data. I think the challenge for them was their data set was very messy. And so they had over thousands of records with a lot of unstructured, noisy text. And so they started where most do, with OpenAI, right? And they said, okay, let's see if we can go ahead and prompt engineer our way to success. When that didn't work out, mostly because of quality, they said, okay, let's go ahead and try RAG with more of a search and retrieval workflow where they go ahead and went ahead and inserted context dynamically into their prompt. And to be honest, even this didn't really meet the quality benchmarks. And so they had heard of fine tuning. They had the data set and were like, okay, let's go ahead and try this out. And once they tried fine tuning, they were kind of astonished with just the success and the quality that they saw. Specifically, they went ahead and fine tuned a Llama 3 8 billion on Predabase, achieving around 98% accuracy. They were deployed on around half A100. And because this was just their first use case, they were so happy with Predabase that they're actually planning to expand to multiple use cases using the multi-LoRA serving technique we saw earlier. So this is the use case. How much did they save? So if you were to look at OpenAI versus Predabase with their workload, so again, their workload was around 160 tokens for an input, output was around 10 tokens, and their volume was around 60 requests a minute. So about 1 request a second, 86K requests a day. On OpenAI with GPT-4, this would run you about 170K per year. And on Predabase, this is around in the range of 20 to 30K. And so with all the optimizations that Predabase offers, they actually still have the capacity to add additional use cases, again, via LoRax at zero marginal cost, right? Because they have this hardware and they can go ahead and add additional adapters for free, right? And so this is one use case that we love to see with Checkr. There actually is another one. And so in this case, this is actually more of a high volume use case. In this case, we're talking about a customer service software provider. Their use case is really around summaries and how can we summarize call transcripts. Of course, the volume here is much, much larger. So they're trying to classify millions of call transcripts every hour. And the specific task that they have is they have these transcripts and they want to go ahead and summarize it and break them out with custom fields, right? So in a very structured way. So they use Predabase not only for fine tuning and serving, but also for experimenting. So they went ahead and kind of experimented with a bunch of different model variants because again, we have this sort of model garden where you can go ahead and try things out. They tried Mistral, they tried Llama 3, and they ended up kind of fine tuning Llama 3 on a few thousand rows. We got a little bit in between 3.5 and GPT-4 performance. Once they added synthetic data, they were able to actually match GPT-4 performance to go ahead and expand their data set to kind of meet the quality benchmarks. And so this is, again, where synthetic data comes in to play, where you can go ahead and increase your data set size as a way to maximize your fine-tuning data set, as well as increase the ultimate performance that you're looking for, right? And so we can see here in the top right that the final performance that they had was actually rivaling GPT-4 with synthetic data. Cool. And so again, you can imagine, hey, what were their cost savings, right? Because they have really high volumes. How much did they save in Predabase? And so if we think about their annual inference cost, what it would be at full scale, if they were kind of feeding in all of their use case, all of their volume. Again, for their use case, the input was 1,500 tokens, so a little bit of a larger input. And then they're trying to summarize it into like a 400 token or so output. For this use case, we'll say it's around 2K requests per minute, around 3 million per day. Of course, with this volume, they required a setup of like multiple A100s. But what this ultimately resulted in was around a 94% reduction in cost, right? Where with OpenAI, it would have costed them over like 10 to $12 million to go ahead and serve this at scale. Whereas with Predabase, you can go ahead and serve the same use case, but in a very task-specific way, using, again, these smaller fine-tuned open source models to go ahead and get that over 90% reduction in cost, right? And so overall, both of these use cases, we've sort of seen just the power of both quality in terms of these smaller fine-tuned open source models, but then obviously the cost savings, right, that are really just undeniable here. So I want to pause here and make sure that we kind of had a chance to digest this. And then I'll go ahead and actually jump right into the demo of customer support automation. Let me go ahead and pull that up. And of course, if there are any questions, feel free to message in the chat. Cool. So hopefully you all can see my screen. Here we have a demo of the Predabase platform. So before I dive in, I do want to mention that everything I'll show you today is in our web UI. We also do have a corresponding SDK where you can do all of the things I'll show you programmatically as well. So jumping back into the UI, we can start by kind of looking at prompt playground. And so what this allows you to do is go ahead and query any open source LLM, both the base model as well as the fine-tuned adapter. And so what I'll do here is actually just warm up this LLM deployment, and then we'll come back to this and show you some real use cases in just a bit. So I think let's start by looking at the data set that I want to show you today. So again, this is really a customer support use case. And what I've done is, let's go ahead and actually just look at the data set. So we see that the two main columns I want to call your attention to, one is the prompt, which is the input, and the second is the completion. And so what we can see is that for this input, we're going to say that, hey, this is your support agent for this company. You're receiving a request from customers. And we want you to do two things. One, we want you to go ahead and classify this into an intent, so sort of like a triage type use case, and then try to give an appropriate response, right? And then we go ahead and give the request that we want to feed into the model, right? Then in terms of output, what we're looking for is actually just a structured JSON, where again, we have that intent field, which is actually just a fixed list of intents that we use for classification. And then the response, which you can imagine is like a sort of a draft response back to the user, right? Because they have this, they have this thing that they're concerned about, that they're complaining about. Can we go ahead and automate the responses actually using LLMs as well? And so by putting this in a JSON, we can go ahead and use this in downstream applications as well pretty seamlessly, right? Cool. So this is the data set. What I've actually done is I've split it up into 3 different use cases. So one is around accounts. And so you can see that the types of queries that people have are really around, hey, can I remove my account? I want to go ahead and reset my password. Maybe they're a little frustrated here, and so on. And we actually have a very similar use case for both orders and payments. So if we go to payments, we can see that these questions are really more around like, hey, can I get a refund? What's your policy? I want to ask for rebates, showing my invoice, etc. And for each of these, this is actually just the prompt template that's wrapping the excuse me, that's wrapping the input. So given all of that, let's go ahead and see how this performs, right? So I'll go ahead and go back to, in this case, I have my Mistral 7B instruct v3 or v0.3. I can go ahead and just query this base model right out of the box, hit run, and start to see those responses. But what I really want to do is actually see, hey, how does this base model, in this case, it's an instruct tune model, compared to the fine-tuned adapters. And so what I've done actually beforehand is I've went ahead and trained some adapters that I'll go ahead and query. And we'll actually dive into kind of how that training process works as well. But in this case, let's say we have like an account example. So in this case, we're a support agent, and they're asking for, can I get help with refunds, right? We see that, okay, the intent was check refund policy, and it looks like it's a pretty like high level answer. Doesn't really give me much recourse in terms of what I can do as a next step, right? And again, this is when we're just querying the base model. So now what I can do is actually I can see, okay, let me go ahead and go to my accounts adapter, which again is our fine-tuned model. Go ahead and select the version. I'll go ahead and use my latest version and run the same query. Right, and so what's happening now is we're going ahead and feeding this input into the adapter, and we'll see that, okay, it was able to get the right intent, but we'll also see that the response is much more detailed, right? And specifically, they're saying, okay, it looks like you're asking about refunds and how you can go ahead and do that. Here are the cases where refunds are actually useful, all right? And they go ahead and list out the different use cases. Obviously, once you format this, it'll look a little bit more neat. But you can imagine that this is like much more useful for a customer support department, right? Where they can actually take this and make a few edits and go ahead and send this off back to the user, right? But again, the value or the way you can get this is by fine tuning, right? And so if I was to show you maybe one more example, what we can do is we can actually go to, let's say, our payments adapter, put in a different, let's see, maybe we do orders. And we try this. And so let's say in this case, they're saying, hey, I can't afford this order number, go ahead and cancel it. We'll go ahead and again, now feed this into this adapter. And we see that we have kind of a detailed response here that is kind of based on prior responses that the company has used, right? Which again is kind of put in the fine-tuning data set. If we go ahead and say, let's go ahead and query the base model just to see the difference, we can see that the base model is just very, very brief, not very helpful, and just kind of actually avoids the question altogether. And so the one thing I want to call out is that, okay, now we've seen the differences between the fine-tuned model performance and the base model performance. How is this actually working? So behind the scenes, you can see that this is actually the same LLM deployment, Mistral 7B instruct v0.3. And what we're doing is we're actually using LoRax behind the scenes to go ahead and swap in these adapters at runtime, right? And so the way I'm able to go ahead and query this adapter versus this different payments adapter is all via LoRax, right? And so behind the scenes, I actually only have one deployment that's running, but I'm able to kind of serve multiple use cases pretty seamlessly, right? And so just kind of want to emphasize that capability. So now that we've seen kind of fine-tuning versus base model performance, how LoRax works with our fine-tuned adapters, let me go ahead and just walk you through how I trained that model before this, right? And so what we can see here is, let's say we have an accounts adapter. What you're looking at here is actually what we call an adapter repository. This is, it's sort of a GitOps style approach where you can easily track and manage all of your experiments across fine-tuning, right? So you can see I've trained 6 model versions. I can see both the description, the base model I used, as well as the underlying GPU, as well as like how long it took as well. And so what I can do is I can obviously go into each of these adapters, go ahead and look at the loss curves and parameters that were used for training. But I can also go ahead and say, hey, let me go ahead and create a brand new one, right? And so here I can go ahead and, again, just choose the data set that I'm looking for. If I want to just verify, yep, this is the data set. Let me look at some examples. We have a convenient data set preview that you can use while you're going ahead and training. But then, yeah, you want to just say, okay, let me choose which base model I want, the data set, as we talked about earlier. And then you can go ahead and just choose the parameters that are most interesting to you, right? And so here we have some of our most popular parameters in the UI, but we also have an extensive configuration that's available behind the scenes in our Python SDK if you're looking for more control or configurability. One thing I'll note is actually we have this new Turbo LoRa feature that's already active and available. And so you can actually just activate that with a checkbox. And again, what this is going to do is it's going to do that whole joint training of LoRa plus speculative decoding to go ahead and make sure that your inference and your throughput is much, much faster once you go ahead and run inference within Predibase. But yeah, it's really that simple. Go ahead and select your parameters, and then you can go ahead and hit train, and we'll kick off training for you. So with that, we've gone ahead and covered our prompt playground. We've covered how you can go ahead and connect data. And again, you can connect data from a variety of different sources, from a local file upload to even things like S3, BigQuery, and Snowflake. We've covered a brief overview of how you can go ahead and train adapters in the platform. Maybe the last thing I'll cover is actually just deployments. So you can go ahead and create a deployment pretty seamlessly. You can just choose the base model that you want, give it a name, select a GPU that you really care about, and then go ahead and hit deploy. And again, once you've deployed that base model, you can then go ahead and LoRax as many adapters or as many fine-tuned LLMs that you want on top of it. Cool. So with that, I'll go ahead and maybe hand it back to Michael for the Q&A.
We'll do some live Q&A, and let me just actually pop something up real quick for folks here. Hold on one sec. My screen up. Trying to get up my screen here. So maybe as I'm pulling this up, why don't you just share with us, Abe? There's a couple questions about one, just restating what an adapter is, and how does LoRax know which adapter to serve? What's the right one? Maybe talk a little about that at a high level, and then I'm going to share my screen here.
Yeah, totally. So in terms of just to reiterate what an adapter is just the small set of pre-trained weights that are trained using LoRa-based fine-tuning, right? So 2 main ways to fine-tune, full fine-tuning in LoRa. If you're using LoRa, the output of a LoRa-based fine-tuning is what we call an adapter, right? The other question was, what was the other question?
How does LoRax know which adapter to serve?
Yeah, totally. So basically it works through a smart scheduling technique. There are like three main features of LoRax, right? One is your like dynamic adapter loading. The second is like a smart scheduler. And then the third is this idea of like continuous batching. And so we have a blog post that kind of dives into all of that we can share as well, if you're curious to learn more.
Great. Abe, what is like some of the most common use cases that we get a lot of questions like this, common use cases you're seeing with our customers today, where they're seeing both performance and gains and then cost improvements?
Yeah, I think there's probably like three main use cases that come to mind. I think the first is actually surprisingly just like classification, right? It's surprising to see that a lot of the same use cases that people did before before LLMs are still kind of around today. So I'd say classification is definitely one. The other two that come to mind are one, like NER, so extracting out specific tags for data, and then the third is probably like summarization, right? Which is, hey, I have a large blob of text and I want to summarize that either into like a structured format or just a general synopsis, right? Are probably the top three use cases we see across our customers.
Got it. And then someone was asking, how does like Predabase specifically work with like structured data sources like BigQuery, other data warehouses that are out there? How does the kind of maybe talk about the data connectors and data sources a little bit?
Yeah, totally. So we've tried to make this like as simple as possible, where we don't require you to like save or persist any of your data in the platform. All we require is actually your credentials. And what we'll do is when we go ahead and run a training job, for example, we'll go ahead and pull that data in real time, use it for training, and then kind of remove it using a time to live, right? And so with that, the data never like lives in the platform. It's just used as needed. And so that way you can be kind of rest assured with like data privacy. And of course, if you're very, very concerned, we also offer like VPC deployments, right? Where the data and compute never even have to leave your environment, right? Yeah.
Great. There's a question actually back on one of the use case for the second customer round, how they're evaluating the responses. I'm not sure if you have the like knowledge on this or like the quiz approach that they're employing. If you can speak to that a little bit.
I actually don't have the full information on that, but we can definitely get back to whoever has that.
That's okay. Alex also responded in chat with some details.
I actually more familiar with the workflow.
Yeah.
It's a pretty common way that people are starting to evaluate summarization models, which is imagine you have a long form kind of transcript or text, and then you want to evaluate how well are you doing on the summarization. What you ask is a large LLM to generate a quiz based on the information in the long form text of the transcript. And then you ask that same LLM to then answer those questions from the quiz using only the shorter summary as context. It's a way to understand how much of the critical information from the longer transcript has made it over to the summary. And one of the ways that we see people evaluate summarization tasks.
Yeah, there was another question. I think it might have been in private chat about like, hey, how would you help someone assess like the cost savings of like open source and Predabase versus like what they're paying with OpenAI today? How would you address that?
I'll drop this in the chat, but we actually can assess this in a first call with customers. And essentially what we look for is just what's the load that you're looking at and what's the use case. For the next few customers, we're also piloting a program where we will guarantee you the cost savings after the 30-minute conversation. Guarantee you anywhere from 30, 40, 50% plus cost savings over what your current deployment is. So if that's of interest to you, please do reach out to us, john@predabase.com, or you can reach out to mine. I'll just drop a note of it in the chat right now too.
Great. Oh, yeah, this was one that came up earlier. There's always pretty common question around, sort of like the licensing and use of open source models. I think we have some, excitement for the new Llama 3.1 and distilling that, but maybe either you, Abe, or Dev want to talk about our perspective on licensing and how to use them and how we think about that.
Yeah, I think this is definitely, I think, probably more of a concern earlier, where different people that went ahead and pre-trained had different licenses. I think what we're seeing with like Llama 3.1, especially with the 4 or 5B, is actually the main use case is like distillation. And so they're actively encouraging people to go ahead and use this model for synthetic data generation with very permissive licenses. So I think our general advice is obviously check the licenses for any model that you want to use, but I think in general, the trend is towards more permissive licenses, especially with open source models.
And I know there's been a lot of interest in synthetic data generation. You touched on a little bit earlier with that use case. I'm curious if either of you thoughts on the opportunity for synthetic data generation, how to help. I know we have a webinar come up, but things that people should be thinking about with regards to that.
Yeah, I think one, if you're curious about it, definitely join our webinar next week. We're going to cover it in a lot more detail. But two, yeah, I think as I mentioned, I think one of the key challenges that we see a lot of enterprises especially have today is they don't have the data set to go ahead and fine tune, right? Like fine tuning is this idea, maybe they're bought in, they kind of get everything, but it's like, what is that initial blocker to go ahead and fine tune? And it often is just like having that fine tuning data set, right? And so we see distillation as just a mechanism to go ahead and create that data set as quickly as possible so that you can go ahead and validate, does fine tuning work for my use case? And if so, I can get these 90% cost savings that we covered today.
Got it. Going through the questions, if I missed any from earlier, got a couple minutes left. Okay, I think that's about it. I'm looking through here unless I missed one. Either of you see? Okay, a couple minutes to spare. I'll just reiterate what Dev mentioned. So one, try Predabase for free for 25 credits. It's enough to fine tune Llama 3.1 and serve it for a couple use cases. You can see, kind of run through what Abe did, and we have tutorials for that. Two, we have a pricing calculator on our website, so you want to see what the cost savings is, and we'll be happy to actually, as Dev mentioned, do a custom sort of analysis of your use case for you, showing you both sort of like cost savings and potential to improve sort of the accuracy on those models. And three, we are piloting a program with a select group of customers where we will guarantee the cost savings against OpenAI. So happy to explore all those with you. You can email us. And thank you, everybody, for joining us. Love seeing the global crowd and pretty big audience today. And we'll see you in just over a week for the next webinar, which I posted there as well. So thanks a lot, everybody. Enjoy the rest of your day, and we'll catch you on the next one.